Hello, it's a wonderful thing to be in your midst to speak with you on the topic titled Recent Scientific Discoveries with emphasis on the importance of mathematics. I am Dr. Animashan Isaac Larry from the Department of Mathematical Sciences, the Federal University of Technology, Akure, Nigeria. I consider this to be a great privilege to be in your midst to share one or two things with you. But before I proceed, I would like to appreciate the organizer, which is the Department of Mathematical School of Physical Sciences, Central University of Karnataka, India. I really say thank you to you. And also, it's important for me to appreciate the co-organizer, which is Department of Mathematics and University of Sri Venkateswara University in India. I say thank you very much for this wonderful program. And it's important to say special thanks to my friend, Dr. Hen Sandip, for this wonderful invitation. So I consider this to be a great privilege to be in your midst to share one or two things with you and to call your attention to the importance of mathematics in the recent scientific discoveries. Science is very broad. We have social sciences, physical sciences, and we have life sciences. The first thing we're going to do is that we're going to describe science and call your attention to how mathematics is being carved out of it. The next thing we are going to consider is called mathematics, which can be categorized as applied and pure. So I will call your attention to this subject, which is very important, which is a subject that almost everyone must offer, started from preschool to the university, and I would like to show you how important the subject is. The first study we are going to consider, it has to do with motion of hybrid nanofluid. There has been a kind of recent publications on it. A lot of research work has been concluded. So I'll pick one and share with you the importance of this and the scientific discovery. I will call your attention to how important this particular fluid is. Also, destined for me to take a step further and share with you recent discoveries within the scope of Ternary hybrid nanofluid, which is another kind of nanofluid that is more advanced than hybrid nanofluid. There has been a kind of recent publications on it. There has been a lot of findings published. So I pick one, even two, and share with you the important, the scientific discovery, and let you see how it's being useful in our real life. Oxygen and carbon dioxide, they are two things that we are familiar with in biology. So this time around, I will take a little step further to share with you recent published facts that has to do with the level or perhaps prediction of dissolved oxygen in any water bodies. So this is another recent observation that is very important because oxygen is almost everywhere. So I will share with you recent published facts on the subject matter. The last study, it's kind of findings that some researchers have embarked upon for the past 9 years. But to be candid, they've concluded the whole research and they're able to come up with a 3D map that can help us to understand the universe. And you know, we can't throw away the fact that universe is very important because we are on the surface of a particular planet inside the universe. So this study is very important because it brings our attention to some important facts which cosmologists and astrophysicists they've been dealing with, and I will let you see how important the outcome of the studies are. And then the next thing will be the first keyword in the definition of science has to do with the usage of the mind creatively. And at times refers to that one as intellectual. if you can use your mind creatively to achieve something, to process an idea, then we can say that you are intellectual. So that is the first thing about science, but it doesn't stop there. It has to do with practical activity. That is, whatever you are processing your mind about, you can practicalize it. Another thing now is systematic study, because there's a procedure you need to follow, and the procedure must be acceptable. You can't just say you're a scientist and you are doing things alone and nobody knows about it. You can't just say you are doing something without following a procedure that is acceptable. That is another important thing about science, because it's encompassing the systematic study of the structure and behavior of the physical and natural world. So whatever we are studying, we just have to follow a particular procedure, which is very, very important. Of course, definitely, we just have to follow observation and experiment. That is the reason why we have social sciences, physical sciences, and life sciences, even and some other aspect of sciences, because not all of them has to do with experiments. There are some there are some scientific discoveries that has to do with observation. Just like I will present to you as the fourth study, it has to do with observation. And at the same time, there are some scientific discoveries that it comes at the outcome of an experiment, which, as in the case of biological sciences. So, as you can see now, you will see clearly now that you agree with me now that science, it has to do with usage of our mind to process something creatively, and practical activity, because it has to do with procedure that you must follow, and it must engage, you must act, it has to do with observation and experiments. So the last thing now is it has to do with a way of studying or trying to provide answers to unknown question, and that is one thing about science. So if you can see anybody that's able to provide answer to any situation and able to process the mind, process the idea creatively, and engage in the practical activity, and follow a particular procedure that is well known by others, and then it has to do with true observation or experiment, then that is what we are going to refer to as scientific discovery. As simple as the subject, mathematics is a compulsory university course. Almost all the universities in the world, they consider it to be a subject, a course that every student must know about it. In fact, starting from preschool up to the university, you see that almost everybody must offer mathematics and English. Why? Because one, it has to do with the set of instruction that can help individual to acquire problem-solving skills. Not only that, thinking skills is another thing that students can really acquire through the study of the subject. And we have reasoning skills and numeracy skills. In fact, economy of thought is another important skills that students can easily acquire when studying mathematics. And that is the reason why there is no research, there is no research output, where they will not consider one or two key factors of mathematics. In fact, it's just a subject that is also valuable in helping individuals to solve societal and individual problems. Just show me a man that is having issue with society issue. What they have to do is to consider survey research, as in the case of sociology, or perhaps they subject the person to some experiment where they can get values, and that values will be very useful to solve the problem. And even individual problems, it has to do with variables, relationship, So this subject is very important to the extent that it can help to solve so many problems. In fact, I would also like to speak on this, that when we are talking about ways to improve human efficiency in memorizing, mathematics is the subject. So you now see that based on this now, almost all the university students must just have to offer the course. Because if at the end of the day, there's an assurance that you acquire problem-solving skills, thinking skill, reasoning skill, numeracy skills, In fact, you will acquire economy of thought. And then even ability to memorize, it will increase. So that is the major reason why mathematics is almost everywhere. In fact, there is nothing you want to talk about that you not see mathematics there. Even if it comes to the minimum, which is the length and breadth, length, addition of length, subtraction of breadth, and some other things. So you cannot see that mathematics is very important, and we can always see it in almost all area of research. Just like I've said earlier, do you know anybody that wants to improve the ability to memorize things? Just recommend algebra, geometry, and calculus to the person. And there's no way you study these three key subjects in mathematics that you will not just have a kind of a logical method of memorizing. It will help a lot. Likewise, if you see anybody that have kind of low level problem solving skills, they will just dislike mathematics. People that don't really find it difficult to think about how to solve a problems, they may just easily dislike the subject. I don't like it because it's a subject that will force someone to really think about problem and methods and the techniques to actually solve the problem. As a matter of fact, mathematics is scientific in nature because it's the abstract science of numbers. And not only number, it has to do with quantity and space. So that is why we can say that it's scientific in nature. So just remember the other time that I call your attention to the key words in science, you will see that it has to do with intellectual usage of our mind to process an idea in such a way that you can actually practicalize it. And that is the same thing with mathematics. So that is the reason why mathematics will always be referred to as mathematical sciences, because it's the abstract side of science, which has to do with numbers, quantity, and space. And tell me a research that there's no number. Tell me a research there's no quantity. Tell me a research that didn't have to do with space. That is the reason why mathematics is almost every aspect of research. Recently, there was a kind of discussion that led to the fact that sciences and discovering, it has to do with physics, biology, and chemistry. But there is also mass inside of sciences and discovering. And that mass is located in such a way that the same mass is also in arts and creating. When we're talking about poetry, you see mass there. When we're talking about music, mathematics is there. Even when we're talking about painting, mathematics is there. And this same mathematics is also in physics, biology, and chemistry. And that is why if you look at it now, we cannot say that if you have to use the concept of set theory, we cannot say that maths, it belongs to art and creating. And at the same time, it also belongs to what? Sciences and discovering. And that is one important thing about mathematics. In fact, because of this, we cannot say that mathematics is a universal language. Because if it's a language that we must speak in art, creating, sciences, and discovering, then which means that this subject called mathematics, it has to do with something, it's very useful to understand our physical world. And that is why you see that in history, arts, physiology, sociology, even in politics, economics, and other aspects, you will surely see that mathematics is everywhere. So this is just to tell you that mathematics is far beyond the ydx. It's far beyond it, because whenever we're talking about numbers, and we're talking about space, and we're talking about measurements, then you see that all these things, they are far beyond the ydx. But one thing about the ydx is that it just let us know the rate of change. Based on this, I think you cannot agree with me now that logic is in philosophy and it's also in mathematics. Yes, that's true. So, based on these three figures now, you can see that mathematics is very important. It's very, very important. It's very, very important. Before I close this chapter, I think we need to consider pure and applied, because when we're talking about algebra, it's more or less in pure. And when we're talking about geometry analysis, there are key subjects, key topics in pure mathematics, and which is just a kind of area that people find it somehow challenging, but as a matter of fact, is the fundamental basis of applied mathematics. And when we're talking about modeling, algorithm, and simulation, it's within the scope of applied mathematics. And that is why you can see that people, when you see them explaining some physical situation after solving their models, is because they are dealing with applied mathematics. So as a matter of fact, we can say that pure mathematics, it has to do with the abstract concept of mathematics. So we have that aspect, and it's just abstract because it has to do with some key facts in algebra and the key facts in geometry and analysis. So we can refer to that one as abstract concept. The other category is just applied, and just like I've explained before, that it's very common in physics and engineering, because in physics we have to do with modeling, and even in engineering too. So when we're talking about modeling, algorithm, and simulation, it's very common in physics, engineering. So that is why we refer to that one as applied mathematics. And in this area, you can see people are able to explain some things, and that is why most scientific discoveries, it's always within the scope of applied mathematics. But don't forget that applied mathematicians, they are using the language of pure mathematics. So that is another thing that we really need to put into consideration. But does that mean pure mathematics is not significant? No, because it has to do with in-depth understanding. If you want to understand geometry very well, and you want to get the best out of analysis and algebra, in fact, including number theory, I'm telling you, the best direction is pure mathematics, because it's not only in-depth, it's very elaborate, and it's very deep. It's very deep. So that is why we have we call it pure mathematics, because it's very broad and it's the fundamental basis upon which applied mathematics is built. There are many kinds of fluid in the industry, but recently, particular author considered 3 of these fluids and considered when nanoparticles are being mixed, colloidal mixed with this fluid. But before I proceed, what is methanol? We call it methyl alcohol, and that is C830H. This fluid is very important in the industry because it's highly versatile. It's a highly versatile chemical substance, and that is why many scientists consider it whenever they want to deal with a fluid in that category. In electricity generation and then in factories, the major reason why they normally consider this fluid is because it's an energy carrier. That is just the reason, because when we're talking about energy carrier, in fact, methanol is always considered because of its efficiency. Either we blend it with gasoline, or we want to use directly as a fuel. One thing that we're very sure is that methanol is indeed energy carrier. But oftentimes, experts in the industry, they prefer to use methanol because it's very cheap to produce. In fact, if you are to compare the production of methanol with others alternative fuel, we just see that methanol is very cheap. So in terms of low production cost, that is the reason why they normally consider it in the industry. And in terms of flammability, methanol has a very low risk. It has a very low risk, and that is why some experts consider to use methanol because it improved safety. And this is fluid number 1 that the author considered. Let's go to the second fluid. When we're talking about antifreeze and coolant, there's a particular fluid that's being used just to achieve these two things, and the fluid is called ethyl glycol. And it's just commonly used in many commercial industrial applications just because they want to achieve antifreeze and they want to use it as a coolant. Now, let me now call your attention to the fact that during winter, ethyl glycol will keep the car engine from freezing. It won't allow it to freeze. And at the same time, this fluid, it acts as a coolant just to reduce overheating in the summer. So that is the reason why the fluid is just being used by many experts. Because if you look at the same fluid that can do two things, it can it can keep engine from freezing during winter. That is when there is cold everywhere. And at the same time, during the summer, it will also serve like a coolant to avoid it to avoid overheating. So these are the two things that make ethyl glycol to be an important fluid that many experts normally consider. Because one important thing is that there's need for the coldness of any machine to be consistent. The machine should not be too cold and should not be too hot. And if any expert is looking for a way to achieve this, then ethyl glycol is the most preferred fluid substance. Now, let's take a look at this now. When we add ethyl glycol to water, that's H2O, the freezing point of that water will just drop as low as minus 60 degree Fahrenheit. So this is the second fluid. Like before, I've called your attention to methanol, and this is ethyl glycol. Now let's consider the third fluid that the author considered. Whenever we want to achieve lubrication, engine oil is always considered. In fact, many scholars are of the opinion that the main role of engine oil is just to lubricate the engine parts in order to maintain constant friction. But it's very important for us to know that the friction between the mechanical parts sometimes causes the engine temperature to rise. And when this happens, then engine oil is needed to reduce friction. That is why engine oil is often considered as a kind of liquid that is very useful to reduce friction and which tends to increase the parts wear. In fact, the engine oil acts as a cleaning, cooling, and sealing agent. It does not allow the engine to corrode, rather it cools it down. So because of that, we can say that this particular fluid, it leads to less damage to the mechanical part, allowing the engine to just run smoothly for much longer time. So that is why people always consider mobile oil or some other kind of oil that's very important, that's very sensitive for this. So we can see now that this oil is very important in any industrial process. Now that I've introduced some fluids to you, now let me now call your attention to what is called nanofluid. Many years ago, some scholars discovered that the thermal properties of base fluid would definitely change if nanometer-sized particles are added to heat. And that leads to that name called nanofluid, called engineer collider of base fluid together with the base fluid, which may be either metals or non-metals. Such a category of fluid called nanofluid has been proved to be very useful, has cooling and vehicle thermal management. In fact, it can be used to reduce the temperature and at the same time for the enhancement of temperature distribution. Even in terms of microelectronics and pharmaceutical processes, nanofluid has been proved to be a fluid that is very, very useful. Many years after, some researchers discovered that if two kinds of nanoparticles are added, then such a fluid can be called hybrid nanofluid. This time around, we're not talking about the addition, we're talking about the engineer collider mixture of a base fluid with two different types of nanofluid. And this is what we refer to as hybrid nanofluid. After the emergence of this fluid, then increasing knowledge of hybrid nanofluid can be traced to its unique improvement of thermal performance and enhancement. Many experts have been using the fluid. They confirm it that there's a kind of improvement of thermal performance. And with this kind of hybrid nanofluid, there are some cases that can also be used for enhancement of heat transfer. In fact, in terms of cooling, in terms of coolants, it was also proved that hybrid nanofluid is very, very important, that it plays a significant role. Before we now consider the exact research work, let's quickly take a look at what is called Lorentz Force. It's just like a force that is being exerted on a charged particles. So if, for instance, now methanol or ethyl glycol or any of the fluid that I mentioned earlier, which I know we all know that they are electrically conducting fluid. Okay. Now, if this kind of fluid, if they're in motion like that, and they experience this kind of force, then one thing that we are very sure is that the magnetic field is significant, the electric field is also significant, and then the charge of the particle is what is q, and the velocity is v. And the research has proved that mathematically such Lorentz force can be estimated by using the expression on the screen. So which means that whenever we are talking about electrical conductive fluid, just like all the three fluids I've mentioned earlier, Lorentz force is always there, is always significant if provided we have the electric charge and magnetic field. Then Lorentz force, it now becomes something that many scholars may not assume it to be insignificant. Another important thing that most times we cannot really ignore it is thermal radiation. It's just like electromagnetic radiation that is emitted from materials, and that is due to the heat of the material. And in such a case, the characteristics of which depends on the temperature. And an example of thermal radiation is the infrared radiation emitted by common household radiator or perhaps electric heater. And in most cases, we can easily see that this thermal radiation is dependent on the temperature of the wall. And when this is there, then in that case, there is possible for us to consider nonlinear thermal radiation, which is most reliable and most sufficient to really give us a practical incorporation of the occurrence. Another thing to really support the fact that nonlinear thermal radiation is the best is that characteristics of thermal radiation, it depends on so many things, and one of them is the surface temperature. And whenever we model thermal radiation using nonlinear model, we always know that there will be a particular parameter that will quantify the ratio of the wall temperature to the free stream temperature. And second thing is the smoothness or roughness of the surface is another thing that can also that can also help us to determine the nature of thermal radiation. And the third one is spectral absorptivity. And the fourth one is spectral emissive power. These are the four most important things that normally affect thermal radiation. The third one that is also important that we need to consider is called dissipation, viscous dissipation. Most time when you see a car moving, we should bear in mind that the car is working based on the engine oil, based on the petrol that is being used. But when the vehicle is moving, then we can say that there is a kinetic energy. And when this kinetic energy is ongoing, it is being released into the atmosphere, and that is a waste. Even sound is being released into the atmosphere, and that's also what sound. So which means that as the car is moving, then there's a dissipation of heat and sound. Now, what is now dissipation? Dissipation is the process of converting mechanical energy into thermal energy. Sometimes some people consider that it's not only to thermal energy, that there is also something called acoustical energy, which is also another kind of energy that we are not familiar with. But one thing that is certain is that whenever we see any fluid that is moving due to viscous forces, it's possible that there is a conversion of mechanical energy too into another form of energy. Viscous energy dissipation is not the energy produced by the formation of a fluid, or simple dissipation, which is the quantity that converts fluid dynamics with thermodynamics. So in summary, what we can now say is that when we have the motion of nanofluids, there are some certain things that we may not really ignore. And the first one that we've considered is the Lorentz force. We've considered thermal radiation, and this third one here is called the law of dissipation of energy, which is a viscous dissipation. This is also another important thing that we cannot always ignore. In this year 2022, there was a particular published fact. Sandy Peter 2022, they consider the dynamics of three different types of nanoliquids. And the first one is this: they consider methanol, which I've explained to you earlier. And they consider this particular nanofluid conveying titanium alloy and aluminum alloy. That is exactly the first hybrid nanofluid they considered. The second category, the second hybrid nanofluid they consider is actually ethylene glycol. They consider this same ethylene glycol too, conveying titanium alloy and aluminum alloy, which makes it two different hybrid nanofluid. The third hybrid nanofluid they consider is engine oil. And this engine oil, they assume that this oil, it's made up of, it consists titanium alloy and aluminum alloy, which make it to be three different hybrid nanofluid. Now, what they're actually trying to consider now is that when these three hybrid nanofluids, of course, we can say that they are non-Newtonian they are non-Newtonian fluid, but they also consider the fact that in this kind of fluid, the best model is Carson. So the Carson model was actually adopted to simulate the flow. And they are of the opinion that in this kind of case, if convectively heating occurs at the surface and the fluid experiences what is called Lorentz Force, at the same time non-linear thermalization occurs, then viscous dissipation is significant. Likewise, its source. So when this are happening, what can we say about the transport phenomenon? In fact, in all the results, we can easily see the effect of convective heating at the wall. So this convective heating at the wall, the effect is something that cannot be covered because it has to do with changes in the temperature gradient. And when there is a change in the temperature gradient, definitely the temperature at the wall will vary significantly. So this is the first thing that is easily observable in their results. And what they now say is that temperature distribution that we are talking about across the fluid, that it actually increases because of increasing of the magnetic strength. Now, do you know what this author is trying to say now is that what they've discovered is that when there is a fluid flow and this fluid experiences Lorentz force, this force actually makes the fluid flow to be very slow. And when the flow is slow, then it's possible that the heat distribution across it will be within a particular domain. And in that case, the escape of heat energy will be minimal. And in such a case, of course, you are talking about a fluid that is flowing very slow. So the heat distribution across it will be increasing because heat energy will not travel away. There will be a kind of consume. The fluid will consume the heat. So what the author is talking about is that in all the three hybrid nanofluid, the temperature across it will definitely increase if magnetic strength is increased. And that is one important result they are talking about. In fact, the dynamics of the three hybrid nanofluid was also shown to be a property that decreases due to higher magnetic parameter. Then what this author is talking about is that by the time this Lorentz force I introduced to you earlier on is being increased, the force, it's perpendicular to the fluid, which tends to really reduce the momentum of the fluid. And when this happens, then there is need for us to bear in mind that increasing this particular force, it can never make the transport phenomenon to be faster, but instead it will make it to be very slow. What about the increasing dissipation now? The author discovered that increasing Eckert number causes the distribution of heat energy in the domain to be an increasing property. So what they are trying to call the attention of experts is that when the dissipation of heat energy continues, this can actually cause a kind of increasing in the distribution of heat, because as this thing continues, then there will be an increasing in the conversion of mechanical energy to thermal energy, and this conversion is still within the domain. And what they are trying to say is that physically the rising Eckert number is associated with increasing irreversible process by means of which the work done by force on adjacent layer due to the action of shear force is transformed into heat, and the heat is still within the fluid domain. Another important thing the author is telling us is that the temperature distribution is actually an increasing property of volume fraction of nanoparticles. What the author is saying is that if we should continue adding more volume of nanoparticles to the fluid, that this will actually cause the distribution of heat, I'm talking about the temperature distribution, to also increase, which means that the higher the volume of the nanoparticles, then the higher the temperature, which means that the more amount of nanoparticles being added to the hybrid nanofluid, definitely we should expect an increase in the temperature distribution. Now we shall proceed to the second study. And this second study here is talking about the dynamics of ternary hybrid nanofluid. And don't forget that in the last slide, in the first study, I call your attention to the published result by Sandy Beta, which they actually consider nanofluid and hybrid, and in the sense that the hybrid nanofluid, it contains two kinds of nanoparticles. Then thereafter, after the usage of the nanofluid, then there has been a kind of development, and the development now is, what if 3 kinds of nanoparticles has been added? That's true, that's possible. What if we didn't consider only just 2 kinds? What if there are 3 different kinds of nanoparticles, even of different shape? What is it all about? Now, this called for the attention of Turner in 2021, which the result was published recently now. And in the study, they actually consider copper nanotube, aluminum oxide, and graphene. Those are the 3 nanoparticles. And all these nanoparticles, they have a small density. Their density are very, very small. They're very small. In addition, they also consider another ternary hybrid nanofluid, that the density of the nanoparticles, they are very large. And that is why they consider copper oxide. They also consider copper and silver. These 3 nanoparticles, their densities are very large. That's another thing they actually consider. In the study, what the author was actually talking about is that when this nanofluid, I'm talking about ternary hybrid nanofluid, flow through a rectangular closed domain, how does suction and stretching affect the dynamics? If the ternary hybrid nanofluid is made up of smaller density nanoparticles, that's case study 1. Case study 2, when the nanoparticles, they have large densities, that is another category of ternary hybrid nanofluid. So they are of the opinion that when these 2 fluids pass through a domain, how does suction and stretching affect them? That was the study. That was exactly what the study is all about. In the study, it was discovered that at all the levels of suction and stretching ratio, that higher Nusselt number were actually found in the case of water conveying copper oxide, copper, silver nanoparticles, and this is actually due to their heavy densities. So what this scholar they are talking about is that when higher heat transfer rate is expected, when the expert actually wants the heat transfer across nanofluid to be very fast, then they should consider nanoparticles that have heavy density. That is what the study is actually talking about, that the heat transfer across hybrid nanofluid, I'm talking about ternary, that consists of 3 different nanoparticles, when the density are small and when the density are large, that they are quite different from one another. But if higher Nusselt number, which is proportional to heat transfer rate, if it's expected, then the scientists should, the engineers should pay attention, they should consider nanoparticles that have heavy densities. What about if nanoparticles have different shapes? What if these tiny particles that are spherical, or perhaps they are oval or cube, or triangular or octohedral, or they are cylinder, or they are platelets, just like we can see on the screen? What if we have different shape of nanoparticles? Then what does it mean? Now, Timofefa, 2009, he was of the opinion that the viscosity of alumni-based nanofluid at various value of temperature, it's actually different based on the shape of nanoparticles. What this author is saying is that the dynamic viscosity of fluids differs with the nature, with the shape of nanoparticles. As a matter of fact, such differences in the agglomeration and interaction between each type of nanoparticles and the base fluid are associated with surface charge. Now, you will not agree with me that in the case of spherical nanoparticles, and then let me consider cube, you will notice that the surface charge of both of them will be different. And that is the reason whereby any nanofluid that is made up of a different shape of nanoparticles, there's need to use another model, because what the surface charge of these nanoparticles differ from one another. It differs from one another. In fact, this findings is in good agreement with the conclusion by Sahu and Saka in 2009. And what did they say? They said that the nanoparticle shapes affect both the exergetic and energetic performance. So based on this, we can now say that there's need for us to really pay attention more to these dynamics. What if the nanoparticles have different shapes? How does it behave? How does it affect the transport phenomenon? Thermomigration, which is also known as thermophoresis, and then erratic or random motion, which is also known as Brownian motions. They're actually some of the attributes that affect the heat performance and then transport phenomenon of almost all the nanofluids. What I'm trying to say is that when all these things are happening, then there's need for us to study fluctuation of friction, heat and mass transfer rate across the ternary hybrid nanofluid. But what Salim is attending to the actually consider is that if in the five ternary hybrid nanofluid we have spherical nanoparticles, and we have cylindrical nanoparticle, and we have platelet, and actually the base fluid is actually water. That's H2O. To further explain the aim of the study now, in the first fluid flow, carbon nanotube, which is cylindrical, is fixed, and then graphene, which is also platelet, is also fixed inside the dynamics of water. But the spherical nanoparticle there is silver, and the density of silver is 10,500. That is for ternary hybrid nanofluid 1. Now let's consider the ternary hybrid nanofluid 2. We also have carbon nanotube, which is cylindrical, and we have graphene platelet, which is inside the water. They are colloidally mixed with water. But copper spherical is actually considered, and the density of copper is 8,933. Okay, that one is for the second ternary hybrid nanofluid. Now let's consider the third hybrid nanofluid. In this case, we have carbon nanotube, which is cylindrical, and we have graphene, which is platelet and inside water. But that of spherical there is copper 2 oxide, and the density of copper 2 oxide is 6,320. So the same thing applicable to ternary hybrid nanofluid 4 and 5. As we can see that each of these nanofluid, they are made up of decreasing density of spherical nanoparticles. The simulation was carried out, and then the first thing they discovered is that if in all those five ternary hybrid nanofluids, like I've explained earlier, one thing that is very certain is that we are going to have a minimum friction if the spherical nanoparticle used is silver, which is highly dense. And at the same time, the maximum friction will occur if we should use aluminum oxide as a spherical nanoparticles. So what this result is saying is that density of spherical nanoparticles actually affect the friction that will happen in the case of ternary hybrid nanofluid. And the friction here is talking about the friction between the last layer of the fluid and the wall. That is what it's talking about. Another important thing that the author notices is that the friction will actually is actually something that we can have in the case, for instance, in the case of our silver, we're going to have a minimum friction at the wall, but towards the free stream, that is upper layer, where there is, I'm talking about the upper, the free stream of the flow, that there will be a kind of maximum friction there. There'll be a maximum friction. And in all those 5 cases, actually, we notice that the most minimum friction will happens at the wall. That is if silver is used. In the case of silver spherical, and then carbon nanotube for cylindrical, and then platelet, which is graphene nanoparticles. And then another thing now is that if you look at table 4 and table 5 now, you will see that the first one is actually when the volume fraction of nanoparticle is very small, that's 0.1. And when the volume fraction of the nanoparticle is very large, that's 0.8, we can still notice something that there will be a kind of increase in the friction, which is actually significant at the wall and in both cases. But at the middle, that is talking about a point ahead, that is a point at a few distance away from the wall, that we are still going to observe a kind of increase in the friction due to changes in the density of the nanoparticle, which is spherical. But towards the free stream, that the friction will actually decrease. So which means that this result is telling the expert dealing with this fluid is that even if at all they observe a kind of friction that is decreasing in these 5 cases at the free stream, but what is happening at the wall is quite different. It's quite different. And in addition to that, the authors are also of the opinion that haphazard motion of nanoparticles, it's something that can actually reduce the concentration of the fluid. We're talking about the concentration of ternary hybrid nanofluid there to be the dependent variable. But what the author is saying is that if the erratic motion of this nanoparticle should increase, if the thermomigration of this nanoparticle should increase, then this will definitely cause a kind of decline, in the sense that it will make the concentration of the nanofluid to reduce. That is what the author is saying, that we should expect a kind of decrement in the concentration, because as this nanoparticle keep on moving left and right, the more they continue moving erratic, and at the same time, if this nanoparticle should continue to move from the region of higher temperature to lower temperature due to temperature gradient, this will actually cause a kind of decline, a kind of decrease in the concentration of the ternary hybrid nanofluid, so that by the time we get to the final destination, the concentration may not be as expected. One thing that we don't normally take note of during the byproduct of aquatic plant photosynthesis is that oxygen is introduced into the water. As a matter of fact, if you remember from the knowledge of photosynthesis, you will notice that oxygen plays a very important role. Even that is why some people believe that human beings, we are married to the plant, because it has to do with the exchange of oxygen and then carbon dioxide. So whenever we see any byproduct of aquatic plant photosynthesis, one thing we should bear in mind is that oxygen is actually introduced. In fact, algae and underwater grasses, they also release oxygen during this photosynthesis we're talking about. All these things that are the seabed, they are at the bottom of most water, of most water bodies. So algae and then underwater grasses, they also try to introduce oxygen, during the photosynthesis. But one thing that we should now note is that oxygen dissolves in surface water That is during the aeration action of winds. When you see wind blowing over water, over sea waters, oceans, one thing that is actually happening is that the oxygen is actually dissolved. There is a kind of dissolve of oxygen. In fact, a small amount of oxygen, up to about 10 molecules of oxygen per small volume of water, is actually expected to dissolve in most water. So, what about air and water? What is the amount of oxygen concentration in both air and water? One thing that we are very sure is that oxygen concentrations are much, much higher in air, more than water. In fact, it is about 21% oxygen than in water. I'm talking about 21% of oxygen in air more than water, and which is a thin fraction of 1% oxygen. So, when dissolved oxygen becomes too low, fish and other aquatic organisms cannot survive it. In fact, the cold water we normally talk about is actually good to hold an oxygen. Underwater aquatic life also requires dissolved oxygen to live, and in fact, to even prosper. But there are some factors which can actually affect the amount of dissolved oxygen in aquatic ecosystem. For example, pollution is one. Water temperature, bacteria, all these they are capable to affect the amount of dissolved oxygen in aquatic systems. In fact, there is a kind of off-chain reaction that kills aquatic life and potential spread of disease to human, because all these animals we're talking about, they are very useful to ecosystem. So that is why we can't afford to lose all the animals in the seawater and animals in the air. We can't afford to lose all of them. They all need oxygen. In the United States National Science Foundation supported study, engineer Homer Abdulaziz, he developed a very simple but effective model, and this model is actually capable to predict dissolved oxygen in streams across the United States Atlantic coast. What this man is saying is that actually there has been a kind of continuous measurements, or perhaps prediction of dissolved oxygen, but most of them all those models has to do with so many parameters. So what he's not trying to say is that all those things can be matched together to give us a novel concept that contains only two parameters. At the end of this study, there has been a lot of comments on it, and among them, Bruce Hamilton, who happens to be the program director in NSF's Directorate for Engineering, remarked that this research that this man is talking about, that this research has provided a tool that can be used to identify regions with oxygen deficient water resources. In fact, with that, it's potentially enhancing their opportunities for improvement, because once any water resources has been identified to be oxygen deficient, then something important can be done, even in terms of sustainability of the animals. In fact, as a matter of fact, Abdulaziz's research found that streams in the southern US, most especially in Florida and Georgia, for instance, have a higher metabolism. What does it mean? It means that they contain less dissolved oxygen, and due to warmer temperature and the high level of nitrogen and phosphorus. In fact, water quality in rivers and streams has degraded throughout our nation, the world, and that was what Abdulaziz indeed said. He actually confirmed that there's been a kind of low quality of streams and rivers in the United States. And he further said that if the water quality is not good, then you end up with low oxygen. And just like we need oxygen in the air to breathe, aquatic life such as bugs, fish, and flora, they also need oxygen. In fact, if there is not enough oxygen, there can be major deaths, and the decomposed matter can spread disease to humans. That is what this man just said. You can see now that what he's talking about now is that even in here, there's it for us to determine the amount of dissolved oxygen. And with this model, it's good enough to let us know, which means that based on this model now, someone can even know a kind of environment that is not good enough for our health. Actually, as a matter of fact, the more parameters, the more uncertain are the prediction. That was exactly what Abdulaziz further said. And that was the reason why he was looking for another methods, another models that will be dependent on just only two parameters. In fact, even said that the important drivers are typically nutrients, temperature, atmospheric pressure, stream width and depth, pH and salinity. And it was like we brought this together in a simplified model to reduce uncertainty in the prediction, resulting in the output of dissolved oxygen. That is very wonderful. Look at that. You can see here now that mathematics is very important, because all these things here is talking about numbers. And don't forget what I've said earlier, that mathematics is just like a language of numbers. And that is what this author, Abdulaziz, is talking about. But as a matter of fact, Abdulaziz has tested his model on streams across the United States, even in Atlantic coast, which revealed discrepancies between northern and southern regions. In fact, even concluded that poorer water quality was identified in southern streams of United States. According to him, Abdulaziz, he said that this issue of poorer water quality that was identified in certain streams is due to warm water temperature and the presence of nutrients and narrower and at the same time shallower streams. That is the reason why you observe something like that. The fourth study we are going to consider now is the 3D map of the universe that has been ever made. According to NASA, cosmology is defined as the scientific study of the large-scale properties of the universe as a whole. This means that it's a kind of intellectual, practical activities which has to do with the study of the universe, galaxies, dark energy, string theory, dark matter, and some other things. But what I'm trying to do, just to provide answer to some unknown questions. Cosmologists, they spend quality time actually over exotic concepts, and most of the concept they battle with, that has to do with string theory. Other one is dark matter. There's another one called dark energy, which may be somehow strange to many people, and they also spend quality time trying to let us know what whether we have one universe or there are many universes. And some of the things they actually study is the galaxy. In the early history of astronomy, Earth actually regarded as the center of all things, which means that other planets and stars, they are orbiting planet Earth. But around 16th century, the story changed. And that was when Polish scientist Nicolaus Copernicus, he actually suggested that Earth and the other planets in the solar system, that they are in fact orbiting the sun, which means that all the planets, including planet Earth, and they're actually trying to move around the sun. In the late 17th century, Isaac Newton also calculated how the forces between planets, specifically the gravitational forces, interacted. And that is very applicable in astrophysics, because all the planets, they're like a ball distance away, in which there's a kind of gravitational force between any two planets. And what Isaac Newton here is saying is that there's a kind of force which is called gravitational force, which actually interacts between any two objects. In fact, Albert Einstein also proposed the unification of space and time in his general theory of relativity. According to him, he was of the opinion that if gravity can actually affect time and light can create gravity, then, as a matter of fact, light can affect time. In fact, he concluded that there are ways that times can be altered, which means that as time goes on, it's possible for someone to travel through time, not only through the space. In recent decades, cosmologist Stephen Hawking, he determined that the universe itself is not infinite, but it has a definite shape. What this man is saying is that the whole universe that we don't really understand, that it has a shape, it has a size, which we cannot determine till now. Nobody can determine the size of the whole universe. But what this man is saying is that after his own research is that the universe, we should not take it as something that is infinite, that it indeed have a definite shape. What about the planet? According to Hawking, he was of the opinion, or let me say, he concluded that the planet is finite, but a person that is traveling around it will never find the end of the planet. Why? Because the whole Earth is like a circle, and we all know about the circumference of a circle. So which means that it has no end. If you are moving throughout, if you are moving around the whole Earth, you just notice that if you turn, you will just go back to the same point. It has no end, because it's just like a cycle. But guess what? Hawking proposed that the universe will not continue forever and ever, that it will get to a stage that the whole universe will come to an end. That is not really a good result. But one thing about research is that whatever you come up with, try to make it available to others. Don't just keep it. But according to him now, you see that what he's saying is that the whole universe we're talking about, we're talking about a large body that contains so many planets. And as we hear now, we are standing on the surface of the Earth, and we have other planets like that. And what this man is saying is that the universe that contains all of us cannot continue forever, that it will eventually end one day. So now let's talk about the Dark Energy Survey, DES. This Dark Energy Survey's DES team, they actually observed the sky between the year 2013 to 2019. That's close to 6 to 7 years research. And within that period, they actually make use of 570 megapixel camera to study the whole sky. What about the location? Where were they? They were actually at the Victor M. Blaneo Telescope, Cerro Talolo Inter-America Observatory in Chile. That was exactly where they were for that within that period where the camera was stationed. The survey covered 1/4 of the southern sky, and its exposures included 300 million galaxies. The aim of the project was actually to shed light on the mystery of dark energy. They want to tell us more about dark energy. What about the force that makes up 68% of the universe, and it's accelerating its expansion? That was actually what they really want to capture. Having the map, we believe that it will allow astronomers to understand how the universe began and where it is going next, including whether it will expand forever or it will collapse or rip apart. And don't forget what Hawking also observed, that the whole universe cannot continue forever, that it will surely get to a stage that it will end. And if you look at this research too, what they're trying to say now is that if they can study the whole galaxies, then it can help us to know if the expansion in the universe will continue forever, or the expansion will get to a stage whereby it will reach its limits. When they now combine the data they obtain from at the end of the research with other surveys, then they discovered that there will be something like 3D map, which has helped to cut the minor margins down to about 3%, according to them. That is according to Michael Trosser of Duke University in Durham, North Carolina. But when the results get to Catherine Emmons, guess what she said? She said, this is such a study which is based on incredible, powerful data sets. Because according to them, the data set they are using, they actually obtain it from for good more than 6 years. And according to Catherine Eman, who is also an astronomer at the University of Edinburgh, UK, He said that this information they are talking about that is so powerful to the extent that it can help us to know more about the nature of the universe. So now let's consider some of the results of dark energy survey DES. The collaboration, they actually reviewed some of their results, and according to them, they said that the universe is actually slightly smoother than expected. Don't forget that earlier on they have the opinion that the universe is somehow rough, that it's not that really smooth. But what they are saying now is that when they focus on the observation, they have the opinion that the universe is somehow smoother than what they actually believe it should be before. And this confirmed that the collaboration, which was actually published in 2017, because in 2017 there was also a particular report too that came out claiming that the universe is very smooth in nature. 3D cosmic map provides a record of the universe history. So the data was actually used to come up with a 3D map. And this 3D map can let us know what has been going on in the past and what may actually happen in the future. In fact, for tracking how galaxies spread out over the time, that's another thing again, because based on this data obtained for more than 6 years, it can let us to know how galaxies actually move before the year and even in the future. It can predict. It can be very useful for the prediction of how galaxies will still spread later in the future. Another important thing about the result is that it can assist the cosmologists to indirectly measure the force at play. And what is this force? That's gravitational pull of dark matter, the invisible stuff that constitutes some 80% of the universe mass. And it can help us to know how these things dominate the formation of glasses and clusters of glasses. Lastly, mapping galaxies and dark matter in 3D also allows researchers to investigate dark energy, and then this will help us to understand the force that is pushing the universe expansion to accelerate, because one thing that is very sure is that there's a kind of expansion of the universe, and if there's an expansion, the expansion is due to a particular force, and that means that if you're talking about a force and it has to do with mass times acceleration, definitely acceleration is most important thing there that can let us know about the expansion of the universe. So with the data with the avatar now, it can help to understand the force that is pushing the universe to expand. And even the nature of this mysterious force is one of the major open problem in cosmology. And now that they have the data, they're working on it. But for now, there's a 3D map which can actually help us to understand the universe. So we have some recommendations for you. The first one is that we all need to contribute to the expansion of the body of science, whatever we are doing. Whatever we are studying, we need to bear in mind the definition of science, which has to do with intellectual. That whatever we are studying, we really need to engage our mind in the study. And at the same time, we must make sure that whatever we are doing is something we can practicalize. And it's either we achieve a result through observation or through experiment. And at the same time, we need to follow a procedure that is well known by others. So science is very broad, and this is an open avenue for each and every one of us to contribute and to say one or two things about it. In fact, more experts are needed to understand the language of mathematics. Like I've said earlier, you see that in the 4 studies I've presented, there's no way, no how we can see the hand of mathematics there. And this call for more experts to really understand the language of mathematics. Some people believe that mathematics should give them a kind of direct job, which is very rare these days. And meanwhile, mathematics is so general, it's in every aspect. So whatever you are doing, if you build it on the foundation of mathematics, I am very sure that it will give you a kind of edge. But one thing is that there's always a need for another step after having mathematics as a first degree. So I would like to recommend to everyone that more experts are needed to really understand the language of mathematics. Likewise, we see that in our study 1, it's actually a kind of study that has to do with methanol, ethyl glycol, and engine oil. But in that study, they consider it to be a kind of hybrid nanofluid. And in our study 2, I call our attention to Ternary hybrid nanofluid, which has to do with 3 different kinds of nanoparticles. So I would like to recommend a kind of extension whereby there will be a kind of more study on the Ternary nanofluid where we can make use of methanol, ethyl glycol, and engine oil as the base fluid. I would also like to recommend that it is high time we need to tell others about oxygen deficient water resources. Most of the waters we take, we need to bear in mind that there is a kind of dissolved oxygen there. And if the amount of dissolved oxygen there is too much or is too low, it's too dangerous for us. And this is a very good opportunity for us to tell others about the improvement of oxygen deficient water resources. And at the same time, we need to be very conscious of the oxygen we inhale. The last but not the least is I would like to also recommend to the cosmologists and astrophysicists that they should try to engage mathematicians for further analysis of the data. The data they have, it has to do with 3D map of the universe. But if this data should get to the hand of mathematicians, they can actually come up with something more better than 3D map. So this is a kind of open question to them that they should make the data available so that others can actually exploit, and gradually we can know more about. At this stage, I would like to say thank you very much for listening. I would like to appreciate the organizer of this seminar on advances in mathematical sciences, ICM 2022. I would like to appreciate you for this opportunity given to me to share with you 4 different studies that has to do with the recent scientific discoveries with the emphasis on the importance of mathematics. I would like to also say thank you to my friend Dr. Nsandi for the invitation to come and share with you one or two facts. So I consider this to be a wonderful privilege, like I've said earlier. And I would like to say thank you very much. Thanks for listening. Thank you. Bye. So in case you have any questions, please drop it at the comment section. I will respond to it. Thank you very much. Bye.